Welcome to the video on oxidation states in organic chemistry. It makes sense for us to talk about this during this chapter where we're talking about alcohols because oxygen is one of the key players in looking at different oxidation states in organic chemistry. In order to calculate the oxidation state in organic chemistry, we are going to look at the four things that are bonded to the carbon. In the situation where the thing that is bonded is either a hydrogen and or a metal, and by metal we mean anything that is electropositive, we are going to count that as -1. Any carbon that is bound to our carbon, we ignore, and any electronegative atom, represented here by Z, can be oxygen, sulfur, phosphorus, and or a halogen, we are going to add 1. For example, if we are going to calculate the oxidation state of methane, we look here and we see that we have 4 hydrogen atoms bound to that carbon. So each hydrogen is a -1. -1 times 4 is a -4. So the oxidation state of this carbon is -4. In this example where we have 1 OH added, each of the 3 hydrogens here count as -1. So that's -3 total. And then we have 1 that's +1 in the oxygen right here. And so that is going to be a total oxidation state of -2. If we then talk about a double bonded oxygen, we see that the 2 hydrogens here are going to still be our -2, and then the 2 bonds to oxygen here is going to be +2. So the total oxidation state of the carbon in formaldehyde is 0. And if we take it one step further, where we have a double bonded oxygen and then an OH, so we have a carboxylic acid, we see that we still have our 1 hydrogen that is -1, and then we have our 3 bonds to oxygen, which would then be +3, and our overall oxidation state of the carbon in this carboxylic acid is +2. So if we look at the table, we can see that we go from -4 all the way to +4. We did not show the +4, but that is going to be 4 bonds to oxygen, which is evident in carbon dioxide. If you remember, in general chemistry, we talked about oxidation and reduction, and we talked about oil rig and Leo the lion says grr. In organic chemistry, we think about oxidation a little bit different. We talk about oxidation as being adding bonds to oxygen, nitrogen, and or a halogen, and then we also think about it as breaking bonds to hydrogen or to carbon. Reduction, on the other hand, is forming bonds to H or to C and breaking those bonds to oxygen, nitrogen, and or a halogen. One example shown here is methane, and we're adding to the methane a Cl2. We end up with chloromethane as our product. And so we have taken away an H bond to that carbon. We have added to it an electronegative atom, which means that this overall reaction is an oxidation reaction. If we go in the opposite direction and we go from chloromethane to methane, where we are taking away a bond from the carbon to an electronegative atom and adding to it a bond to hydrogen, then that is a reduction reaction. I thought this figure was very helpful in terms of organizing our organic molecules in terms of oxidation and reduction. Over here on the blue side, we'll see the things that are most reduced. And over here on the red side or on the right side, we're going to see the things that are most oxidized. So as we walk across from reduced to oxidized, as we remove bonds to hydrogen and add them to carbon in terms of a double and a triple bond, we are becoming more oxidized. We also see that if we start with an alcohol, go to the ketone or aldehyde, then we go to the carboxylic acid, and then we go to carbon dioxide, we are increasing our oxidation state. We can also do the same thing by adding more electronegative atoms. So if we start with methane, 1 chlorine is more reduced, then 2 chlorines is more reduced, then 3, then 4. So you can see that trend as well. And it also happens with respect to bonds to nitrogen. As we increase the number of bonds to nitrogen, we are also increasing our oxidation level. So if we bring it back to alcohols, we can see that as we increase the number of bonds to oxygen, we are increasing the oxidation state and we are doing an oxidation reaction. If we are increasing our bonds to hydrogen, then we are decreasing the oxidation state, and that is called a reduction reaction. In this direction, as we are adding bonds to oxygen and removing bonds to hydrogen, we are becoming more oxidized. And in the reverse direction, as we are adding bonds to hydrogen and removing bonds to oxygen, we are being reduced. And the bottom line in this chapter is that if we have an alcohol, we can use an oxidation reaction to bring it to the ketone, aldehyde, or carboxylic acid. But we can also form an alcohol from the aldehyde, ketone, or the carboxylic acid using a reduction reaction. So oxidation reduction is important in this chapter of alcohols, and I hope this little video helped you see that.